Can't they be flipped down?
Yeah.
But how could I ask you just to graph 3 random points and make a parabola? My question is, did you get it right? Did you have it over here to the right and a little bit above, from the origin to the right and a little bit above? Did you graph your 3, 3 and your 4, 9? And wait a minute, I have 5 points up here, but I only asked you to graph 3. How should you have been able to do it, Jonathan?
You just matched down to the side.
Parabolas have symmetry. They fold. And so, Andrew, as soon as I got my vertex, if I got a couple more points, shouldn't I have been able to do the whole thing?
Yeah.
Right? Because if I graph the point 2, 1, if I graph the point 3, 3, if I graph the point 4, 9, to make my parabola, all you guys had to figure out in your groups was copy on the other side and shoot, there it is. Symmetry, like a butterfly. Symmetry. It was the key.
Yeah.
But I said at the very beginning of class, I was like, oh, it's impossible to do until I told you who or what? The vertex. Until I told you the vertex. Question. If I was to show this to you guys, where am I?
Whoa.
Where am I?
Drawing a lion.
Well, Disney Studios.
I'm Disney Studio, California Adventure, the animation studio. Some of you have been there? Hey, raise your hand. Have you guys ever sat in the animation studio?
No.
Only 2 of you have been there? Raise your hand if you've been there. Come on.
Where is it?
Okay, let's explain it. Hannah, you're in a big room, right? What do they have you do?
You like get a board and draw whatever they do on the board.
Now, can you guys tell what they're having you draw?
Michael
Oh,
Wow,
that's bigger. Oh my goodness. Didn't know it'd be that hard. Now, do you guys see the YouTube video? It says 16:07. If I was to play it right now. If you walk into the studio and they say draw Tigger, that's it. They gave you a piece of paper, draw Tigger. How many of you guys would be like, got it?
Me.
I wouldn't. I would suck at drawing. That's why I love going here. Because if I go in there and they tell me to draw Tigger, I'm like, there you go. It'd be awful. It'd be like a stick figure, I don't even know. With like a curly tail. That's all I do. Big nose. But what they do is walk you, hold on, someone else who's been there. Danny, you were talking about it. How do they get you to draw something like a Tigger? Shapes. And they show it to you. They're modeling it, but they're like, hey, do a circle, like about halfway down the page. Do a circle. And they just go step by step. Do you guys see that this, well, you can see Tigger, right, at this point.
Yeah.
But at the very beginning, they show you like, hey, we're going to draw this. Or do they? I actually don't remember. They might not show you what you're drawing. No, they do. They say like, today we're going to be drawing this. But then they just go step by step. Draw a circle. Then like, do a little shading here and then draw a parabola. And then go over here and then draw a bigger circle. They just take one shape at a time. And at the end, like no matter how bad you are at drawing, unless you totally not follow directions, like you have a pretty stinking good, like, hey, I can draw. Well, maybe you can, maybe you can't. You can follow directions. Now, what are some of the key shapes that you guys see in here? Circle, that's obvious. What else?
Oval.
Oval, right? It's not a circle. It's a little bit. Oh, I think at the very beginning, I bet you they had you draw this cross. Because they want you to find like your bearings. They want you to have orientation. They probably had you, isn't that like an X and Y axis?
Oh, yeah. Yeah.
Huh. And what else do you see besides circles and ovals? Do you guys see them? They're everywhere in this picture. I don't know if I see triangles.
I see a lump.
Rectangle.
Rectangle?
I don't know what that shape is.
I see curves.
Curves.
How can we describe some of these curves?
Circle.
How could you describe the bottom of his nose?
Circle.
A parabola, right? Wait, pause. How could you describe the upper part of his nose? A parabola. To be honest, it's like a curved down one that's really spread out. How could you describe part of his ears? Part of a parabola. How could you describe part of a parabola? Part of a parabola. Oh my goodness. Now they're not using the word parabola in the Disney animation studio. But technically, in the world around us, well, this is just animation, but there are so many more shapes than squares and rectangles and circles and lines and what else? Triangles. Almost everything is curved in some way, shape, or form. And how do we describe curves? Now, there's something crazier. There's a different type of function that would describe this kind of curve. It's actually called a sine curve, S-I-N. Some of you have seen it on your calculators. Anyway. Yeah, but S-I-N is a shortened S-I-N-E math function. Anyway. It describes waves, like sound waves and like waves in the ocean and things like that. It's a math form. But anyway, parabolas are what we're talking about right now. But here's the dealio, kiddos. Do you know that? You have to know this. Not all animation is done by hand anymore.
Yes.
You know that, yeah?
CGI.
CGI, yeah. Right? But in the olden days, to get animation, did you guys realize that, don't worry, they'll come back. People had to draw page by page by page, like a flip book, and make it to where the characters would move as you guys, or as they would have the pictures go in order. Now, some of your parents might work at Disney, or you know people that work at Disney. We live so close to like all of the Warner Brothers and the Disney Studios and Universal and all that sort of jazz. You probably know someone that's at least somewhat involved in the Disney empire. But, coming back, just thinking about CGI and thinking about computers, do you guys know that coding, the very foundation, you can start teaching itty-bitty kids how to code, computer code, like write programs. But how they start isn't like putting them in front of a computer and a keyboard and teaching them like the language. It actually says, hey, you want this to move there. How could you get there? It's just teaching them to be like, oh, go up 1 and over 3, and there are all these little activities of just saying, how do you get from this step to this step? How do you go from here to here? This is kind of like that. How do you go from a blank page to Tigger, step by step, with different directions? Now, why am I showing all of this? Well, we're talking about parabolas. We're talking about section 8.4 if you guys look at your worksheet. I gave you 3 points and said, hey, make a parabola, but you had to know stuff about the parabola to do it. But I want you to start to look at this as not just some random parabola, but think, if I was to tell a computer to do this, what would I have to tell it? How could I get it to get there? In order to start thinking about that, we're going to actually go back to the very beginning. You don't even have to take any notes on the very beginning. Ready? Who's y equals x squared? Tell me something. Tell me anything about it. Do you guys remember anything about good old-fashioned basic x squared? Tell me anything about it. It's a formula. This is a formula. Tell me anything.
It has an exponent.
It has an exponent. Good. It's an exponent of squared. We don't read this x2. We read it x squared. What else? It's a variable. Good. Keep going. Just tell me anything about it. Has a 2 in the exponent.
Has equal sign.
Okay. So many of you. Yeah, you're not wrong. You're telling me what you see here. But what else should you know about x squared? Does he have a name? Does he have a shape? Does he have points? What else do you know? He's not called an exponential. He has an exponent. He's actually called a power function. Anything. Point, a shape, anything.
Exponential function,
That's not his name. Starts with a Q.
Quadratic.
Good. His name is a quadratic. His shape, parabola. Quadratic, parabola. X with an exponent of 2. There's a vertex. But do you know where the vertex is?
Middle.
The middle of what?
Graph.
Oh! Like the middle, like 0, 0?
Yes.
Oh, how can we check that? Could we plug in 0 and ask ourselves what happens if we square 0?
Yeah.
What do we get when we square 0?
0.
Okay, good. So the point 0, 0. That's a point. What else do we know?
That's it.
That's it. Anytime you have an equation, you can plug in and get as many points as you want. Wasn't there such a thing as a table last semester?
Yes.
Okay, so hold on. Plug in 0, get out 0. Plug in 1, get out. Oh, so this is easy. It's 1, 1, 2, 2, 3, 3, 4, 4. No, that's a line. Maybe I need to plug in more. What else can I plug in?
2.
Okay, what's 2 squared?
4.
Why should I be able to draw my parabola right now? Because symmetry, just what we did on your post-it, right? Symmetry. If I know this is my vertex, which you guys just called it a second ago, the vertex is this little point right here. We can actually be super snazzy and even talk about how we have this axis of symmetry. That was one of those vocab things from last semester. It's going to be at x equals 0. But I can copy this to the other side, like some of you figured out at the beginning of class and some of you didn't. And I can swoop, there it is, right? What happened between this guy and that guy? What changed? Yeah, that's the beginning of computer programming. They moved. Well, hold on, they moved how? What changed? Right now, this guy's equation, ugh, that's gross. We had to deal with these all before it broke. Well, hold on, it's a big, fat unknown. I just gave you the picture. I just gave you the graph. Well, you guys found the graph. I just gave you 3 points. Told you he was a problem. It's a big, fat unknown, but tell me how it moved, and you're going to be so much closer than you ever were before. How do you go from here to here?
Where?
Huh? Square? Yeah. I think he's already square. What changed? The vertex changed. It moved. How did it move? You guys see this is the point 0, 0. This would be where it was originally. So where did it move? Okay. I'm losing it. I don't know why, but that's okay. My question. Pause. That's okay. Just what's the question? I'm asking what's different. That's it. What changed? How did it change? Where did it move? Okay. So let me try something else. Let's get something that you're familiar with. Does anybody know where this is?
A parking lot. Oh, is that in that?
It's a parking lot. Is it what?
Is that in that?
Is it?
Is it?
Yeah.
Yeah.
Which in and out? The one on
Yeah.
last and in Balboa. Yeah? You guys see the little, and then the line that comes out is always in the street, right? Okay. No? Well, I'll zoom in a little bit. But yeah, it's in and out. Balboa and last and the one that's right down there. Closest to school. Where am I right now?
Outside and inside.
I'm outside the
Well,
in and out.
you're in the classroom, but.
Well, yeah. Good. Put in the picture. I'm outside the in and out. True? If a worker's outside the in and out, what are they doing? You see it? Got a little ready, but a few for people a little bit anyway. Outside. They're working. What are they doing? Taking orders. They have a little like, and they're asking you, what do you want? And aren't they continually moving back and forth amongst the cars?
Yeah.
Well, I mean, they should be, right? They're taking an order, then they're moving over here, then they're moving down here. Okay, I'm trying to simplify this a little bit, but pause. Where am I looking now in the picture?
Inside.
Inside. So there's workers outside, and there's workers inside. What are the inside ones doing? They're moving back and forth with the fries and the condiments, and they're going to the window, and they're getting your drinks, and they're doing all that sort of jazz, right? Let me try to apply this to math. Ready? We have the inside workers, and we have the outside workers. They're doing 2 different tasks. I mean, they're all under the same umbrella. They're under the same company. Hey, in and out. In, out. Anyway, not every in and out like that. I had to steal this one because some of them are all inside. But coming back, in and out, inside and outside, true. What if you thought about this in a math way? Now, I know it's a little crazy. I know it's a little weird. But remember how Tigger was built off of like an X and Y axis? I can put an X and Y axis anywhere. Here's an X axis. Here's a Y axis. Okay? Now, maybe you can't tell, but this is the exact same picture I had a second ago of the outside of In-N-Out with those little workers that are moving outside and those little workers that are moving inside. And I'm just making it super simple in the sense of outside, they're coming up and down the line. Inside, they're going back and forth with all of the cooking and all that sort of stuff. But I've started bringing math in to say, hey, there are inside changes and there are outside changes. And in math, we actually start labeling these with letters. If computers are doing all these things these days, someone had to tell them what to do. But to tell them what to do, they can't just like yell and scream English at a machine. It's never going to work. Okay, maybe Siri can do a few things or Alexa. But as far as programming and teaching a computer to do things, you have to actually speak in its language. Math has a language too, and I'm trying to show you how some of this language works. So if we, oh, I don't want that. And save it. If we take a parabola, a quadratic, if we take that super basic y equals ax squared, Now, a second ago we were talking about just x squared. I threw a little a in, which can be a stretch or a shrink. Talked about that last semester a little bit. There are two other changes that we can put in the equation that can help us describe if this basic dude, if this ax squared dude has changed, or the snazzy math term is transformed. If he's transformed. I can show him moving, like the inside workers, back and forth horizontally, or I can talk about him moving vertically, like the outside workers going up and down the line. But in math, we use these h's and k's to kind of symbolize that or to show that. And usually someone said something really good. I asked how it changed, and they said the vertex changed. That's great. He's like the most important point. He's the lowest, he's the highest, the maximum, the minimum. He's super important. So if we have this inside horizontal way of describing change, and if we have this vertical way of describing change or movement or motion, let's see if we can get back to that question I asked. What changed? We can talk about a beginning parabola, like an x squared, and we can talk about a shifted, a transformed, a moved parabola by just describing, hey, this vertex dude, he's gone somewhere else. And to show that gone somewhere else, all you got to figure out for me is how far right or how far left, how far up or how far down. Put those changes in the right spots, and all of a sudden you got yourself the new equation. Something that we could actually like tell a computer, hey, I don't want the parabola here, I need it over here for this illustration, animation, program, blueprint, whatever it is that I need. Now, let's come back to the very beginning. If you guys are in your notes, now's a good time, but the cool thing is you don't have to draw this graph again, because can't you just put your Post-it in your notebook? Peel it off, it's a Post-it. Peel it off, it's a Post-it. Section 8.4. Yeah. Stick them right here and just leave a little bit of space. Okay, ready? 8.4. This is our objective, to graph a times x minus h squared plus k. You don't need to write all of this, what you will learn. It's in your book. We're trying to learn how to graph equations when they look like this. And to be honest, it's going to be so much easier than how we ended this semester. And I'll show you why as soon as I unveil this book on the side. But let's start with the goal. Let's start with the goal. Melanie, can you read the goal for me out loud? Nice and clear.
Finding key characteristics and graphing shifted parabola.
Is the parabola on your Post-it in your notebook? Has it been shifted? Well, if you think about the very beginning parabola, check it. From a basic parabola. And if you want to, you can put it on your Post-it. The basic parabola. Is the one on your Post-it moved or shifted? The answer would be yes. So if you want, you could go ahead and put that original parabola. With 0, 0, and 1, 1, and 2, 4. If you want, you could put y equals x squared on your Post-it too, to show you, hey, from the very foundational, fundamental, basic parabola, yes, there's been a shift. There's been movement. And someone said, like, the vertex has changed, and that's perfect because the vertex is not the old 0, 0. Can you guys fill in what the new vertex is? Of your parabola and your vertex? What's the new vertex? Good, Andrew. Because the vertex is always the lowest or always the highest. So if we have a graph, just look at the lowest or the highest point. The vertex is so easy to find if you have a graph. And if the book were to ask you axis of symmetry, that's no big deal because these are the exact same. It's just x equals 2. Now check it. I want you guys to just have your practice problems. Do you see any places on here in homework, because these are very similar to homework, do you see any places where you're going to have to fill in these blanks? Do you see them? Okay, right now, can you guys go to every single blank that says vertex, and can you make me an ordered pair, an empty one with a comma? Because that's going to tell you, hey, anytime they ask me a vertex, I'm filling in an ordered pair. So did you see a second ago how I had this written down to try to remind you what we're looking for? Why don't you do that to all the blanks, all the vertex blanks, and all the axis of symmetry blanks? Can you do that on your paper? So anytime you see a vertex word, go ahead and show me this ordered pair, because you're going to have to fill it in. Every single time, every single vertex blank, show me an ordered pair with a comma. Now, what are you going to do anytime you see axis of symmetry? X equals. Yeah. Remember, Armando, you don't need to get like the what you will learn at the top. That's just for you to know. There we go. Second. Okay, do you guys have little empty vertex blanks all over the place every time you see vertex? Cool. Do you see axis of symmetry? Have you put x equals? Now, the problem is, on this worksheet, do you guys see any graphs?
No.
Okay, so Melanie just read a second ago, our goal is to find key characteristics, fill in these blanks, and graph shifted parabolas. So in our notes, we're starting with the graph on your Post-it, but in homework, we're not going to be able to start with that. What do you guys see in numbers like 1 and 2 and 5 and 6? Not graphs, but equations. Okay, so we have to say we don't have the graph yet. And how do we still know stuff? Now, hold on. Just a second ago, for your Post-it, we filled in the vertex is 2, 1. The axis of symmetry is 2. Can you guys maybe draw a little arrow in your practice problems? Anytime we fill in the x-coordinate of the vertex, you can always fill in the axis of symmetry. Can you draw a little arrow like I did to remind you? Anytime you fill in the x-coordinate of the vertex, the same exact number is the axis of symmetry. Because the axis of symmetry is always the vertical line that goes right through the vertex. That's just a quick little like problem solving, making, it's like a cheat kind of, to make answering that question so easy. Now, here's the problem. Right before semester break, we would have said or known or graphed something like this, ax squared plus bx plus c. To be honest, there's this really nifty program. It's online. It's free for anyone to use called Desmos, D-E-S-M-O-S. I typed this in and got this graph. That's how I got it. I typed that in, got that graph. The problem is, do you guys see the 2, 1 in there anywhere?
Nope.
Not really. Like, there's a 2. Where's the 1? I don't know. Here's the cool thing. This section says there's another way of writing this down. There's another way of writing this equation. We don't have to write it in the ax squared plus bx plus c thing. We can write it like this. Now, hold on. What do all your problems look like? Does it look like this or does it look like that? The bottom one, right? Now, what's cool about the bottom one? Check it. I would write this one down. This is the most important one for the section. Do you see the 2? I do. It's inside. Oh, it's showing the inside horizontal movement. What happened? This parabola shifted 2 to the right. That's weird. It's a minus. Yeah, that's just how it works. But 2 to the right. Do you see the 1? Yeah. It shifted 2 to the right and up 1. There was an inside movement and there was an outside movement. That's what happened in my parabola. Now there's also this 2 on the outside that does this stretchy thing. So if you guys notice, he's a little bit narrower too. But we're talking mostly about the movement right, left, and up, down. Remember, in and out? Inside, you're going back and forth. Outside, you're going up and down. So then we can start taking that and using it. Armando, did you get it okay?
Yeah.
Okay. I'm going to go back to this to help us out. Because in your worksheet, we don't have graphs, we have equations, right? In your worksheet, we don't have graphs, we have equations. Now here's a really snazzy vocab term, and I highlighted it. It's called vertex form, and it's the really cool way of writing a parabola where change has happened, but in a way where you can see the change. You can see that the vertex is somewhere new. Ready? Whenever you see an equation like this, this is what's important to write in your notes, so you can use it. Whenever you see an x minus or even an x plus on an inside of a quadratic, we can always say the vertex is at that number, whatever the number is. Just like over here, the 2 shows me that the vertex is at 2. Now, it's tricky. There's a minus in the formula. X minus 2, steal the 2. It's the vertex. Oh, and as soon as I have that, I can say, ha-ha, I know you. So hold on, wait a minute. Number 1, right? Is there something on the inside of that quadratic? Yeah. So my vertex, you guys already have your little quotation marks drawn and your x equals, right? You already have your little quotation marks drawn and your x equals. I'm going to zoom in. I'm just trying to, you have it written down here, right? Now here's the weird thing. Am I allowed to, based on what this says, take him, steal it, and write it? Am I allowed to write a positive 2?
No.
I heard a yes and I heard a no. The yes person, you're really close because you're like, yeah, just steal it, just steal it, just steal it. The no person, you're actually right. Why is the positive 2 not the right thing to fill in the blank with? Yeah, why can't I just write a positive 2 there? Why does it not technically follow this? No, the inside does go first. The inside does describe the x, so why can't I write just positive 2? Andrew?
Because of the equation?
Yeah, the equation's different. What's different about it?
It's a minus.
This one has a minus. My form has a minus, but what does this have? So here's the tricky thing. To rewrite this, to make it look like that, here's what I have to do. Ready? If I were you, I'd rewrite it. It helps your brain. X minus. If I have to make it match that, A is 4. No big deal. 4 is fine. But how do I get a plus from a minus? Another minus. So it's actually x minus who or what? Not a positive 2. It's x minus a
-2.
You guys tracking? If the formula has a minus, what has to have been subtracted to make a plus? A -2. So it is 2, but it's a -2. Now the cool thing is you can make yourself a note right now if you have a highlighter and say, anytime there's a plus, I'm always going to make it a negative on the inside. Anytime there's a plus, you're always going to make it a negative because the formula, the basic formula, always has x minus h. X minus, it's not. Okay, fine. X minus -2. Ha! Figured it out. Here's the weird thing. If the h goes here, if the inside is always the x, what do you guys think I'm going to do with the k? Wait. Why is it 0, Isaiah? If I'm rewriting this, I can put a +0 and say, there's nothing there! Exactly. Hey, look, it's 0. So you guys mimic it to go ahead and answer number 2. If the first one is the point or the vertex, -2, 0, with an axis of symmetry of -2, how would you fill in number 2 then? What's the vertex of number 2?
-7.
-7, comma, 0. You see it? And what's my axis of symmetry? X equals?
-7.
Oh, you guys are rocking it. Now, hold on. Go down to numbers 5 and 6. It's later in homework, but isn't it kind of easier?
Yeah.
Look at number 5. What would your vertex be for number 5?
-3.
-3.
Oh.
And what would your y be?
-2.
-2. Now, I know it's kind of weird. On the outside, the sign stays the same. If it's a minus, it's a negative. On the inside, it flips. This is actually this big pattern in math that exists, and we'll keep seeing it. But for right now, just keep that equation close and these examples close. Wait, what's your axis of symmetry?
-3.
Got it. So how about this guy? What would his vertex be? -5, -4. Axis of symmetry, x equals rocket. So how are we doing on half of homework when they give us equations and say what's the vertex, what's the axis of symmetry?
Good.
Hopefully good, and you're going to have your worksheet closed so that you'll be able to make sure you remember what you're supposed to be doing, right?
Yes.
Okay, but there's one other part to homework. Melanie read, we're supposed to be identifying key characteristics of shifted parabolas. That's exactly what you just did. But what's the rest of what's on
Graph.
3 and 4 and 7 and 8 says graph, right? Sorry. There we go. So how do we use all this to graph? The end of the worksheet, the end of our practice problems, the end of homework, and the end of notes. You ready? In your notes, write this down. So how do we use this to graph? In the notes, how do we use this to graph? How do we use this to graph? Graph the vertex. What? Oh, wait a minute. We just learned how to find the vertex. So if let's not even worry about axis of symmetry. If you guys notice, I didn't tell you to graph the axis of symmetry. The first step to numbers 3 and number 4 and number 7 and 8 is to find the vertex. So if you guys get this written down, go to your practice problems and say, okay, the first step is find the vertex. What is it? The first step is find the vertex. What is it? First step, find the vertex. This is exactly what we just practiced. Awesome. Good, Trey. -1, 0 is for number 3. For number 4, it's going to be
-6. and
-6,
0.
0. Now remember, if there's a minus sign, for some reason I just stole the pluses. I'm sorry. If there's a minus sign, it would be a positive number, but these ones are negatives. Zeros, because remember, that k is missing, so we just could put a +0 if we wanted to make it easier on our brains. But what about numbers 5 and 6? What are the vertices of those? Let's keep doing what we know how to do. What's the vertex to number 7?
-3.
Not negative. Why is it a +3?
Because it's a negative.
Because it's x minus. Good. And then 2 was right. And then what's the vertex for number 8? Negative. Yeah, it's okay. We're getting it down in our practice problems. You guys can use them to remind you in homework. So the very first step is, okay, you guys have to draw little x's and y's. Sorry, I meant to get it in the worksheet. I totally forgot this one. Draw little x's and y's. But the very first step is graph the vertex. -1, 0. Well, he's going to be shifted to the right one. I can actually get him shifted to the right one. -6, 0. He's going to be shifted 1, 2, 3, 4, 5, 6. 3, 2. 1, 2, 3, 1, 2. -2, -4. -2 going down 4. We practiced graphing points at the beginning of class today, right? So the very first step in all of them is graph the vertex. Now hold on, beginning of class. How many points did we need to make the parabola?
5.
5 total, but I had you start by graphing just 3, and then you were able to copy, right? So check what I tell you to do next. The vertex, there's 1 point. Where are my other 2 points? Here and here. And then just copy. So here's what we're going to do. We're going to figure out where our vertex is, and we're going to ask ourselves what x value is 1 to the right, and what x value is 1 or 2 to the right. So guys, what's 1 to the right of -1? 0. And what's 2 to the right of -1? 1. I'm going to take those x values and do what we always could do. I'm going to go plug it in and say, ha, I'm going to find who you are. So I'm going to go ahead and plug in 0. Now we're going to have to do some PEMDAS. But doing some PEMDAS would end up getting pretty quickly just 2. Or doing some PEMDAS to this guy. I can graph pretty quickly. Hey, that guy's supposed to be at 0, 2. So that's going to be another order pair. And this guy's going to be at 1, 8. 1, 2, 3, 4, 5, 6. And what can I do as soon as I have those 3? How'd you finish your post at the beginning of class? Copy it on the other side for 1 left and 2 left. And you're done. But for each of these, you're going to have to ask yourself, where is the vertex? Like in number 7, my vertex is at 3. To go 1 to the right, I would need to plug in 4 this time. And to go 2 to the right, I would need to plug in 5 this time. And I would need to plug it into this equation up here, because the equation changes every time. Plugging in the 4 or plugging in the 5. We have to be careful with some PEMDAS, doing some review. In the sense of parentheses go first, exponents go next. But if you guys can get your points of something like, I see it, 4, 3, and 5, 6, then pretty quickly I can go ahead and copy and swoop. What do you guys need for your homework tonight? Probably your notes and your practice problems. But otherwise, you guys should be able to bust it out and have it ready for tomorrow. Come tomorrow with questions. And if you're wondering what I'm going to ask you about how homework went, you can read the back of your worksheet and say, what am I supposed to be thinking when I do homework? Bye, guys. See you later. Excellent job. Let's see if you can ace this one tonight. Start off the semester with 100%. It's on the backboard if you guys want it, or the front board. It's on the front board, it's on red, it's on the backboard.